Let AB belongs to R be such that the function f given by fx is equal to ln mod x plus bx square plus ax, where x is not equal to 0, has extreme values at x equal to -1 and x equal to 2. Now there are two statements. Statement 1 says f has local maximum at x equal to -1 and at x equal to 2. Statement 2 says a equal to half and b equal to -1/4, and we need to find whether the statement 1 is true or not, and so many things are there connected to it. So let's start doing this question on the whiteboard. We have been given that fx is equals to ln mod x plus bx square plus ax, and the function takes the extreme values at x equals to -1 and x equals to 2. Now we know that the function takes the extreme values when its derivative becomes 0, that is when f dash x turns out to be 0. So first of all, let us calculate f dash x for the given function. So f dash x is equal to derivative of ln mod x is 1 over x, derivative of bx square will be 2bx, and here it will be a. Now it is saying that it is taking the extreme value at x equal to -1. Therefore at x equal to -1, f dash x will be equal to 0. So substituting the x equal to -1 in the above equation and f dash x equal to 0, we will be getting 1 over -1 plus 2b times -1 plus a equals to 0. That gives -1 minus 2b plus a equal to 0, which on simplification gives e minus 2b equal to 1 as the equation 1. Similarly, at x equal to 2 also we have extreme value, that is f dash x is 0 also at this point. Therefore we will be having 1/2 plus 2b times 2 plus a equals to 0. That will give 4b plus a equals to -1/2. This is the second equation. Now we can simplify equation 1 and equation 2 to get the value of a and b. So let us simplify. The first equation is a minus 2b equal to 1, and the second equation is a plus 4b equals to -half. Now if we subtract these equations, what will happen? This is minus, and this will become plus. So a and a will be cancelled out. We will be getting -6b equals to 3/2. That will give b equal to, this 3 will cancel out to 2, so b will turn out to be -1/4. Now let us substitute this value of b in the equation first, that is a minus 2b equal to 1. So in place of b I will be writing -1/4 equals to 1. That gives a plus 1/2 equals to 1. That gives a equal to half. Therefore from this we can say that the statement 2 is correct one, because in statement 2 it is mentioned that a is equal to half and b equal to -1/4. Now let's write the fx by substituting the value of a and b in it. Therefore fx turns out to be ln mod x plus x square times, in place of b I will be writing -1/4, plus x times, in place of a I will be writing 1/2. Now to check the first statement that says that f has local maximum at x equal to -1 and x equal to 2, we need to again take the help of f dash x. So in the expression of f dash x, let us substitute the value of a and b. That will give 1 over x minus x by 2 plus 1 by 2. What we have done in the expression, f dash x is equal to 1 by x plus 2bx plus a, we have substituted the value of p, that is -1 by 4, and value of a, that is 1 by 2. So we get f dash x this way. We simplify the f dash x, that will give, the LCM will be 2x here, so it will be 2 minus x square plus x. If we take out minus common from the numerator, we will be left with x square minus x minus 2 divided by 2x, and if we wish to simplify it, it will be minus of x square minus 2x plus x minus 2 divided by 2x. We take x as common, so it will turn out to be minus of x minus 2 plus 1 x minus 2 divided by 2x. So that will be equals to minus of x minus 2 times x plus 1 divided by 2x. Now let us try to discover the nature of function. How we can do? Let us plot the critical point of f dash x, and they are obtained as, if we equate this to 0, we will be getting x minus 2 equal to 0, that will give x equal to 2. If we take this one and equate it to 0, we get x equals to minus 1, and if we equate it to 0, we get x equal to 0. So our critical points are 0, minus 1 and 2. This is infinity, this is minus infinity. Now we can see that our usual notations will be plus, then the minus, then alternate plus, then minus, and then we check the nature of f dash x. But now here we can see that a minus sign is being placed, so all the signs will be reversed. So we will be having basically a minus here, a plus here, a minus here, and a plus here. So this is basically representing f dash x, the nature of f x, that is whether the function is increasing or decreasing, because if f dash x is greater than 0, that means function is increasing, fx is increasing, right? And when f dash x is less than 0, then fx is decreasing. Now here this positive sign says that f dash x is positive, that is greater than 0. So from minus infinity to minus 1, function should be an increasing one, so it will take its shape something like this. After minus 1, f dash x is less than 0, that means that the function should decrease, so it decreases like this. Then after 0 again it will increase, and after 2 it will again decrease. Now we can see that at minus 1, if this is minus 1, let me make this a bit more clearer. So if this is minus 1 here, we can see a peak is there, so this is the point of maxima, and corresponding to 2 also we are getting a point of maxima. Therefore from graph we can say that we have point of maxima for x equals to minus 1 and x equals to 2. And if we want to calculate mechanically, we can also do that way also. That is, we had f dash x is equals to 1 by x minus x by 2 plus half. To find the maxima, we double differentiate it. So let us double differentiate it. F double dash x will be equal to minus of 1 upon x square minus 1 by 2. Now when we substitute x equals to minus 1 minute, let us see what will be the value. F double dash x is equals to minus 1 upon x square minus 1 by 2. At x equals to minus 1, we have f double dash x equals to minus 1 upon 1 minus 1 by 2. That will give minus 3 by 2, which is a negative quantity, therefore it is a point of maxima. Similarly, if we substitute x equals to 2 in f double dash x, we get minus 1 upon 4 minus 1 by 2, and that is again a negative quantity, that is minus 3 by 4, so which is also less than 0, so it is also a point of maxima. So therefore we can say that statement 1 is also true. Now if we have a equal to half and b equal to minus 1 by 4, we will be having f the local maxima and local maxima of f at x equal to minus 1 and x equal to 2. Therefore it is explaining the statement 1 also. Therefore the correct answer for this question will be statement 1 is true, statement 2 is true, and statement 2 is correct explanation for statement 1. So let's see which is the correct option. It is the B which is the correct one, that is statement 1 is true, statement 2 is true, and statement 2 is correct explanation for statement 1.